Welcome to Study Loop.
This is the answer to Chapter 12, problem number 75 from the Smith Organic Chemistry textbook. And in this problem, we were asked to draw a stepwise mechanism for a Birch reduction, which is a dissolving metal reduction. And specifically, this converts substituted benzenes to 1,4-cyclohexadienes. And it's possible to do with sodium metal, but the yields are better with lithium metal. And it's done in liquid ammonia and with some alcohol. And so basically, dissolving the metal, so lithium in this case, in liquid ammonia allows for the solvation of electrons. So there are just free electrons floating about in the solvent. And that's what really drives this reaction. That's what makes this reaction possible. And so the first step is going to be that one of these electrons, and you could also draw this as a radical on lithium, or you could just draw it as the free electron like this. So this is going to add to the ring, and the electrons of the adjacent double bond there will revert to that carbon. And so after that first step, we have this. So, okay. Sorry, trying to draw a better ring here. There we go. That's better. Okay, so we have this, and we now have a radical, so a single electron there, and we have a lone pair and a negative charge on this carbon. Okay, and so the next step is going to be that the electrons of this double bond are going to shift over like that. And so that will get us to this intermediate. I apologize. It's sometimes difficult to draw rings on their sides like this, but this is how the problem gave it to us, so I do want to just stay consistent with that. Otherwise, I would draw this ring right side up as I think of it. Okay, so we still have our radical here, and our lone pair and negative charge are now on this carbon. And so here is where the alcohol is going to come in. So this is why the presence of an alcohol is required. And so I think we're told to use ethanol for this problem. So ethanol looks like this. And so these, the lone pair of electrons here with the negative charge is going to grab this hydrogen. And so they are taken care of now. Oof. Okay, and so we can just draw the hydrogen there. Okay, and so we still have a radical here. And what's going to happen next is another solvated electron is going to come and add there as well. And so this is going to make a full lone pair on that carbon now. Okay, so double bond, double bond. I'll draw the hydrogen here, I guess, just as a reminder that it's there. There's our methoxide. And so now we have a true lone pair there with a negative charge. So what can happen now, once again, is another equivalent of the methanol that we have, or pardon me, the ethanol that we have, can come and protonate that position, just as it did in the earlier step. Okay, and so this lone pair of electrons can grab this hydrogen, and that's going to actually get us to our final product. Okay, and I guess we can draw the hydrogens here and here. And so actually, of course, there would be two hydrogens at each of those positions now, but that's what's been added, one hydrogen at each of those positions. And so that's the answer to this problem. It's the mechanism for the Birch reduction. And we just need to remember that this is dependent upon solvated electrons, which is why we need to dissolve lithium metal in liquid ammonia. And again, you could, instead of, so where I've drawn the E minuses, adding, you could draw, instead, you could draw a lithium radical donating a radical electron. It's really the same thing. And that's the answer to chapter 12, problem number 75.